we change the order, we add 5 to minus 6. So it becomes minus 6 plus 5 is equal to minus 1. What do we see? In both the cases, answer is minus 1. So changing the order of addition does not make any difference in case of integers. 5 plus minus 6 is equal to minus 6 plus 5, which is equal to minus 1. So we can say while adding the two integers, the order of addition does not alter the sum. This is called commutative property of addition, which holds true in case of integers. Here we have different rational numbers: 1 by 4, which is a fraction, 6, a whole number or a natural number you can say, and here we have a decimal number. All these numbers are rational numbers, as all of these can be expressed as ratio of integers. 1 by 4 is already in this form. 6 can be written as 6 by 1 and 0.5 can be written as 5 by 10. So all these are rational numbers. Let's add two rational numbers, minus 1.5 plus 1 by 3. Here 1.5 can be written as 15 by 10, and putting the minus sign we get minus 15 by 10 plus 1 by 3. Now 30 is the LCM here. Minus 15 multiplied by 3 we get 45, minus 45 that is, and here 10 multiplied by 1 we get 10. So it becomes minus 45 plus 10 divided by 30. Thus the answer becomes 35 by 30 with a minus sign, that is minus 35 by 30. Now let's change the order of addition. So we add first 1 by 3, then we need to add to it minus 1.5. This becomes plus 1 by 3 and plus minus becomes minus, and 1.5 can be written as 15 by 10. Now taking LCM again, 30 and here 10, here 15 multiplied by 3 which becomes 45 with the sign of minus, so minus 45. So we get the answer as minus 35 by 30. What do we see? While adding the two rational numbers, the order of addition does not alter the sum. This is commutative property of addition, and we say commutative property of addition holds true for rational numbers. Now let's see the case of subtraction in case of integers. 6 minus minus 3. It is equal to 6, minus minus becomes plus, so 6 plus 3, and this is equal to 9, that is plus 9. Now if we reverse the order of subtraction, then what does it become? It becomes minus 3 first, minus 6. This becomes equal to minus 3 minus 6, which is equal to, we just add the two numbers 6 and 3 and put the common sign which is minus. So we get here minus 9. So in both the cases answer is different. Here the answer is 9, and when we change the order of subtraction we get minus 9. So what can we say? We say commutative property does not hold true for subtraction in case of integers. Now let us subtract rational numbers and see. Here we have 1.5 minus 1 by 5. Now 1.5 can be written as 15 by 10 minus 1 by 5. Taking LCM, we get LCM of 10 and 5 is 10, and here we get 15 minus 5 2s are 10, so 2 multiplied by 1 we get here 2. This becomes equal to 13 by 10. Now let's change the order of subtraction. So 1 by 5 minus 1.5. This becomes 1 by 5 minus 15 by 10. Taking LCM, we get 10 is the LCM, and here we get 2 minus 15. And this is equal to minus 13 by 10. What do we see? The answer is not the same when we change the order of subtraction. In the first case, it was 13 by 10, and now it is minus 13 by 10. So what can we say? We can say commutative property doesn't hold true for subtraction of rational numbers. So commutative property of subtraction is not true in case of rational numbers. Now let's see multiplication of integers first. 3 multiplied by minus 4, this becomes equal to minus 12, as minus into plus becomes minus and 3 into 4 is 12. Let's change the order. First minus 4 and then multiplied by 3. Here answer again is minus 12, as minus into plus becomes minus and 4 times 3 is 12. So commutative property holds true for multiplication. We get the same answers even when we change the order of multiplication. Now let's see what happens in the case of rational number. Here we have minus 2.5 multiplied by 1 by 5. So 2.5 becomes 25 by 10, and we reduce it. So 5 ones are 5 and 5 fives are 25. Next 5 ones are 5 and 5 twos are 10. So this gets reduced to minus 1 by 2 as we taken into account the minus sign. Now let's reverse the order. We get 1 by 5 multiplied by minus 2.5. This becomes 1 by 5 multiplied by 25 by 10. Again we reduce it here. So 5 ones are 5, 5 fives are 25. Further reducing it, 5 ones are 5 and 5 twos are 10. So we get answer as 1 by 2. What do we see? In both the cases, the answer is same even when we change the order of multiplication. So we can say the commutative property holds true for multiplication of rational numbers. So this was the commutative property for multiplication. Now let's see division. Minus 9 divided by minus 3. These two are integers and answer we get is 3, because minus minus cancel each other and 9 divided by 3 is 3. Now let's reverse it, that is change the order. So it becomes minus 3 divided by minus 9, and here the answer would be equal to minus 3 divided by minus 9. So minus minus cancel each other and 3 ones are 3, 3 threes are 9. Answer becomes equal to 1 by 3. So the two answers are change. The change in order leads to change in the result. So commutative property does not hold true for division in case of integers. Let us see what happens in the case of rational numbers. Here we have minus 2.5 divided by 1 by 5. This becomes equal to 25 divided by 10, and we know division can be changed into multiplication when we take the reciprocal of the number. So 1 by 5 becomes 5 by 1. And now reducing this, 5 ones are 5, 5 twos are 10. So what is the answer? Answer is equal to minus, taking into account the minus sign, minus 25 by 2. Now let's change the order of division. So it becomes 1 by 5 divided by minus 2.5. This gets reduced to 1 by 5, changing this division into multiplication. How? We take the reciprocal of the number here. So this was minus 2.5, or you can say it was minus 25 by 10. And what is its reciprocal? Its reciprocal would be minus 10 by 25. So reducing it now, we get 5 ones are 5, 5 twos are 10, and taking into account negative sign, we get answer as minus 2 by 25. Look here, both the answers are different. They are not same. So changing the order of division changes the result or the answer. What can we say? We can say commutative property does not hold true for division of rational numbers. So this was commutative property for division. That was all for today. Bye bye children.